All right, babies. All right, my babies. Let's go ahead and start our last class. I will see you guys tomorrow, just like yesterday. We're gonna be working on the same packet. We're gonna be working on 7 through 12. So let's go ahead and start. Um, American astronauts working on a space station on the moon toss a ball into the air. The height of the ball is represented by the equation f of t equals negative 2.7 t squared plus 13.5 t plus 14, where t represents the time in seconds. So x is time, again, imagine that. And y would be, and f of t represents the height. To the nearest hundredth of a second. Now this is important because this tells me that I'm probably not going to factor, that I'm probably going to use a quadratic formula, and this is probably going to be a decimal. Usually when you factor, you don't get decimals, you get whole numbers. After how much time does the ball hit the ground? Okay, so they're in space. Remember, just to get a visual, it goes up and then it hits the ground. So I am looking for one of my zeros, my x-intercept of the zeros of the function, okay? And to the nearest tenth of the foot, what is the greatest height the ball achieves? So after how much time does the ball hit the ground? So I'm looking for one of the x's. So the x in one of the x-intercepts. And to the nearest tenth of a foot, what is the greatest height the ball achieves? Now the greatest height the ball achieves would be the maximum, which would be right here. Okay? So I'm going to have to find the axis of symmetry for the second one, letter B. I'm going to call this A and that B. Okay, so let's go ahead and write down a formula. The formula would be negative 2.7 t squared plus 13.5 t plus 14, okay? And there's no way that you can factor this, okay? So we're going to have to use a quadratic formula. So A is the quadratic term, which is negative 2.7. B is the linear term, which is 3.5. And C would be the constant, or the y-intercept, which is 14, I'm sorry. So let's go ahead and write down the formula. Minus B plus minus B squared minus 4AC divided by 2A. And let's go ahead and start plugging in. That negative is going to turn that 13 into a negative. So 13 plus 5 plus 13.5 squared minus 4 times A, which is negative 2.7 times C, which is 14. And the calculator is going to take care of all of that for me. And then 2 times negative 2.7. So let's do this in the calculator. So I'm going to go ahead and write it exactly like I see it. Square root 13.5 squared minus 4 times negative 2.7 times 14. And when I hit enter, I get 164. Let's do that again because I'm not sure that I did it right. Okay, 13.5 squared is 182.25. And then negative 4 times negative 2.7 times 14 is 151. And I'm going to have to add those two because they're both positive. So plus 182.25. There you go. I knew I had not done it right. Now I have to do the square root of that. All right, so inside my square root, let's go ahead and do that again, step by step. Negative 13.5 squared So inside the square root, I'm going to do it over here because I'm running out of space. Actually, let's give me a white paper. So inside the square root, negative 13.5 squared was 182.25. And then that's a negative 4. So negative 4 times negative 2.7 times 14. That will be a plus 151.2. Okay? And then 2 times negative 2.7, it's negative 5.4. Okay, so let's add those two and then do the square root of that. So 182.25 plus 151.2 is 333.45. Now I'm going to do the square root of that, 333.45. Now, I need it to the nearest hundred, so that means 2 after the point. So I'm going to go ahead and get 2 after the point. So I'm going to change the mode to 2. And I'm going to hit it again, and that would be 18.6. So then this becomes negative 13.5 plus minus 18.26 divided by negative 5.4. Uh-oh, you can't see that. I'm sorry. You couldn't see any of that. I guess I need coffee again today. Alright, so this is where you turn into two different problems. So that was negative 13.5 plus 18.25 divided by negative 5.4. Or negative 13.5 minus 18.26 divided by negative 5.4. Alright, so let's go ahead and do that one. The first one. Negative 13.5 plus 18.25. And then I'm going to have to divide that by negative 5.4. Negative 0.88. I'm going to do the next one. Negative 13.5 minus 18.26 divided by negative 5.4. Now remember, these are my two x's, and my x's are seconds. So x can be negative 0.88, or x can be almost 6. Now x is time. Can you have negative time? No, which means your answer is almost 6 seconds, or 5.88 seconds, okay? So the answer would be 5.88 seconds. All right, let's do the next one. On the next one, it says to the nearest tenth, which means I'm going to round it to 1 after the point. To the nearest tenth of the foot, what is the greatest height of the ball? So I gotta calculate my maximum. And to get my maximum, I got to find my axis of symmetry. Okay, so B is your linear term, which is 13.5, but with that negative, it becomes a negative 13.5. And A is your quadratic term. All right. So 2 times negative 2.7. I got to change the mode to 1, correct? So negative 13.5 divided by negative 5.4, that's positive 2.5. And this is x, which would be time, and that is seconds. Now, that's not what it's asking me. It's asking me for the greatest height. This is x, so the height would be y. So now I got to go to the original equation. And plug in that x, or that t, the time. Negative 2.7, 2.5 squared plus 13.5 times 2.5 plus 14. And when you do all that, you get 30.9, almost 31 feet. All right, we're done with that one. We're done with that one. All right, let's go to number 8. Number 8 says, Mr. Jackson had a rectangular shaped garden where the length was, okay, so rectangular shaped garden, let's take it step by step because it's too much information and then this movie gets overwhelmed. The length, okay, so you have the length and you have the width. You don't have info about the width, so that's your x. But you know that the length is 2 less than twice the width. Now whatever goes after then, you got to write first. Twice the width would be 2x minus 2. The area of the garden is 422, so area equals length times width. So that will be 420 equals x times 2x minus 2. You can switch them around when I put the width before the length. So let's distribute that x. 2x squared minus 2x. Now I got to say minus 420, and here is 0, so you get that 0 equals 2x squared minus 2x minus 420. Now I'm going to try to factor. If it doesn't factor, then I'm going to go ahead and use the quadratic formula. GCF would be 2 Okay, so two numbers are multiplied 210 and add up to 1. So this has to be numbers that are very close to each other, okay? So 210 will be 21 times 10. That's not close to each other, will not give me 1. But 15 times 14, what you need to do is just start dividing it by numbers that are divisible by 5, like 15 or 10 or 25, things like that that end up in 0 or 5. If I divide 210 divided by 15, that gives me 14. And that, when I subtract, does give me 1. Now, one of them needs to be, then 15 needs to be negative. So then that becomes x minus 15, x plus 14. So my zeros would be 15 and negative 14. Now, if this is length, would you pick negative 14? No, because there's no such thing as a length of 15. Of negative 14, I'm sorry. So the length has to be 15. So this would be 15, and that is 2 times 15 minus 2. That would be 28. Now, just to make sure that I am correct, that area, which is 28 times 15, needs to be equal to 420. That was the area. So let's see, 28 times 15, ding, 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 420. So this is how you check that you have done it correctly. All right, let's go to the next one. Number 9. All right, so for number 9, we got Jocelyn and Kelly build rockets from the assembly kits and are going to launch them at the same time to see whose rockets flies higher. So we're looking for maximums around here. If Jocelyn's rocket's height in feet can be described, so let's start organizing my information. Jocelyn's is negative 16x squared plus 180x. And then we're missing a negative over here. I'm so sorry for Kelly's. That should be negative. And then for Kelly's is negative 16x squared plus 240x. If it's a rocket, it has to, right, it has to go up and then down, which means it's got to open down, and it's got to have a maximum, okay? Rockets go that way, up and then down. Kind of like Superman flies up and down. All right, who wins the rocket race, which means who has the maximum height? Now remember, for the maximum height, we got to go ahead and find the axis of symmetry. Now the x will be time in seconds, and the y will be height in feet. All right? So the x is always time. The y, 99% of the time is time, and the y would usually be height. All right, so let's find both axes of symmetry. All right, that is your linear term, so that becomes minus 180. 2 times negative 16. 5, when you divide that, is 5.625 seconds. But I don't want seconds, I want height. So I have to go back to the original equation and plug in that x. And when you do that, you get that it will go, I believe it's 506 feet with 25, 606.25. That's Jocelyn's. All right, so let's do the same for Kelly's. Axis of symmetry to figure out the maximum time and then the maximum height. Negative 240, 2 times negative 16. So that's negative 240 divided by negative 32, and that equals 7.5 seconds. Now let's plug in the equation. That x so that we can figure out the height. And when you do that, you get 2,700 feet, and that would be Kelly's. So who wins the rocket race? Most definitely Kelly. All right, after how many seconds does each rocket land? So we got to figure out where do they land, which means my x-intercept. All right, so let's factor. As the first one, let's do the second one right here for both of them. All right, so negative 16x squared plus 180x. Let's see if we have a common GCF, and it does. It's 4x. That will be negative 4x plus 45, which means 4x equals 0. When you divide by 4x equals 0, there's no such thing as times 0. So it has to be the other one. Negative 4x plus 45 equals 0. So you got to do minus 45. When you get down, negative 4x equals 45. Divide by negative 4. And the other x would be 11.25 seconds. We're not going to use 0. We're going to use 11.25 seconds to hit the ground. Because it flies, it goes up to 506 feet. All right, let's do Kelly's. Negative 16x squared plus 240x. All right, GCF would be 16. I'm sorry, not negative, but 16. So 16x, which means you got a minus x plus 15 over here. And that's, sorry, I forgot to put it equal to 0. So 16x equals 0. When you divide by 16, x equals 0. It's definitely not that number. It's not going to hit the ground in 0 seconds. And then the next one would be negative x plus 15. So I got to say minus 15. There's an invisible 1 here. So I got to divide by negative 1, and x equals 15 seconds. Now that does make sense because it goes higher than Jocelyn's. Kelly's goes 2,700 feet. This one only goes 506, but yet there is a difference of 4 seconds in it, okay? To the nearest tenth of a second, what was the difference in time for the two different rockets to reach their respective max height? So the difference in time, you're going to take that 15, the max, this is to hit the ground. The max would be right here. This is to reach maximum height. So it's asking me, that's to reach maximum height, so it's asking me what is the difference between those two. So you're going to say 7.5 seconds minus 5.625 seconds. We need it to the nearest tenth. So I should have my calculator on a float of 1. So 7.5 minus 5.625, that equals 1.9 seconds. So almost 2 seconds. All right. The quadratic problems are not hard. You just really got to know what they're asking you to do. All right, let's do number 10. We're almost done. The product of two consecutive integers is 30. You don't know the integers, but you do know that they're consecutive. So one is x, and to get the next consecutive, you just got to say x plus 1. And you know that their product, which means when you multiply them, equals 30. So x times x plus 1 equals 30. Distribute x2 plus x equals 30. Now I'm going to have to say minus 30 on both sides. So x squared plus x minus 30 equals 0. This is most definitely very factorable, that quadratic. Negative 6, actually positive 6 and negative 5 will give me negative 3, and then when I take away, that will give me a positive 5. So this is x plus 6, x minus 5. So what are my zeros? Negative 6 and 5. Now let's think about this for a second. If the product is 30, the numbers cannot be different signs. The numbers have to be the same sign. So what are my two numbers? Either positive 6 or positive 5, or negative 6 and negative 5. So we got two options in here. It can either be both numbers that are positive, or both numbers that are negative. Because both of those will give me, when I multiply them, positive 30. All right, let's go to the next one. Last two and we're done. All right. An object is moving in a straight line. It initially travels at a speed of 6 meters per second, and it speeds up at a constant acceleration of 4 meters per second. Each second, the distance d in meters that this object travels is given by the formula. D equals 2t squared plus 6t, where t is times in seconds. So x equals time in seconds, and then y has to be height. And this one is in meters. And how do I know? Because it's asking you, according to this equation, how long will it take for the object to travel 108 meters. So you have that the distance would be 108. So let's plug it in. Instead of a D, you're going to write 108. Now we're going to say minus 108 on both sides. 0 equals 2t squared plus 6t minus 108. GCF would be 2. So this is x squared plus 3x. I substituted the t's for x's. And half of negative 04, negative 108, I'm sorry, would be negative 54. Now two numbers that will multiply to negative 54 and add up to 3. 9 times negative 6. You can see it, I'm sorry. 9 times negative 6 will be negative 54. And 9 minus 6 would be 3, which is the middle term that I need. So this would be x plus 9, x minus 6. So x equals negative 9, x equals 6. If we're looking for time, we're definitely not getting the negative one because time is not negative. So the correct answer would be 6 seconds. That's how long it will take. All right, and the last one. As illustrated below, a frame for a picture is 2.5 inches wide. The picture enclosed by the frame is 5 inches longer than it is wide. So I've already telling you that you don't have any information about the width, so that would be x, and that the length is 5 inches longer than, that's your backward word, so that's your x plus 5. If the area of the picture itself, so this is the picture, this is where the picture is 300. Determine the other dimensions of the frame. So what do I need? I need that and that. Because I already know the ones from the picture. I need the frame. Okay, so area of a rectangle is length times width. The area is 300. The length is x plus 5. The width is x. So let's distribute that x. X squared plus 5x. Now I got to say minus 300 so that I can equal it to 0. So then I got x squared plus 5x minus 300. So I got to multiply two numbers that will give me 300 and add up to 5. 20 and 15, when I multiply them, is 300. And if I say negative 300, I'm sorry. If I say 20 minus 15, I get positive 5. All right, so this adds up to x plus 20 and x minus 15. So what are my zeros? Negative 20 and 15. Now, common sense again, I cannot have a length that's negative 20, so my x would be 15. So from here to here, I have 15, but from here to here, I have 2.5, and then from here to here, I have 2.5. So the width of the frame would be 15 plus 2.5 plus 2.5, which is 5. So it would be 20. And the length is 15 plus 5, which is 20. But then I have 2.5 here and 2.5 there. So to that length, I have to add another 5, and it would be 25. So the dimensions of the frame are 20 by 25. All right, guys, that was about maybe another 35 minutes of class, of the video. About 30 minutes, I'm sorry. So what you're going to do now is you're going to take the second sheet that you should have in hand, and you need to go ahead and do this one, okay? You need to graph all those graphs in there, okay? All right, babies, I'll see you guys tomorrow. I miss you like crazy, but I'll be there tomorrow. Love you, babies. Have a good one.